So in this video we're going to go over converting between cylindrical and rectangular coordinates in space. We're going to do two examples. So in the first example we're going to convert cylindrical coordinates to rectangular. In example 2 we're going to convert the other direction, rectangular to cylindrical, and there's going to be a subtlety in it that we're going to address based on the quadrant that we're located in the XY plane. So the first one here says convert cylindrical coordinates to rectangular coordinates, and we recognize that cylindrical coordinates means that we have r, theta, and 3. So it's just simply a matter of using those relationships that we established when we did polar coordinates and then throwing in the z equals z. So our coordinate in the cylindrical system is 2 pi over 3 and 3. So in the rectangular system this is going to be equivalent to, and our x coordinate is going to be r cosine theta, so it's going to be 2 times the cosine of the 2 pi over 3, and then it's going to be 2 times the sine of 2 pi over 3, and z equals z, so the 3 is just going to be 3, and then we need to simplify, so we're going to get 2 times, okay, what's the cosine of 2 pi over 3? Well, the cosine of 2 pi over 3 is going to be negative 1/2. 2 times the sine of 2 pi over 3. So the sine of 2 pi over 3 is going to be the square root of 3 over 2. And then this is just 3. If these weren't special angles, then we would just leave it the way that it is, unless we were asked to approximate the coordinate system in the or the rectangular coordinate. So if they weren't a special angle, you would just stop right here. Like if it was 3 radians, you'd go 2 cosine of 3, 2 sine 3, and 3, and you'd be done. And then we want to do one last simplification, so we're going to get a negative 1, comma, square root of 3, comma, and 3. So on the next slide we're given a rectangular coordinate and we want to convert into the cylindrical coordinate system. So we're going to use our two relationships coming to us from polar coordinates or trigonometry, and again z is just going to equal z. So we've got negative square root of 2 comma square root of 2 comma 3, and this will be equivalent to, and what we want to recognize is that we're working here in the xy plane. We want to work to get our r and our theta in the xy plane. So if we think about what's going on in the xy plane, we have the ordered pair over here at negative square root of 2 comma square root of 2. So we just use the Pythagorean theorem, which is this relationship right here, to get r. So we know r squared is going to equal the sum of the squares of the x and the y components. It's just an application of the Pythagorean theorem. And when we square this, we're going to get a 2 plus, and we square this, we get 2, so we get r squared equaling 4, which means that r is going to be equal to 2. So we have a radius of 2 sitting here, so it's going to be radius, comma, now we need to calculate theta. We know that z is going to equal z, so the coordinate z here is still going to be here. We need to get theta. And what we want to recognize is if we're using this relationship, the tangent of theta equals y over x. So in this case we would get the y coordinate is the square root of 2. We'd get root 2 over x, which is negative root 2, and this would be negative 1. And so if we take the tangent inverse of this, so theta would wind up equaling the tan inverse of negative 1. What we want to recognize is that the tangent inverse function is going to give us an angle between negative pi over 2 and pi over 2. So if this weren't a special, if the side ratio right here didn't correspond to a special angle, which it does, and you just use the calculator to get the tangent inverse, you would get the wrong angle. So you would wind up getting the angle down here that corresponded to the point square root of 2 comma negative square root of 2, because the tangent of theta is negative 1 down here in quadrant 4. So the calculator would give you this angle negative pi over 4 radians. And we would need to rotate that result 180 degrees or pi radians into quadrant 2 to get the angle that we actually wanted. So we were just grinding this out kind of mechanically. What I'd want to recognize is that the point that I have is in a quadrant for which the tangent inverse doesn't give me an angle. Tangent inverse gives me angles in quadrants 1 and 4, not from quadrants 2 and 3. So really, the angle would be this angle plus, I need to rotate it by pi radians. So the calculator would give me negative pi over 4, and then I would need to add pi radians to that, which is the same as adding 4 pi over 4, which is the angle 3 pi over 4. Because I have a special angle, I probably could have recognized that I'm at, here's 45 degrees, 45 degrees, 45 degrees or pi over 4 radians 3 times. I have 3 pi over 4. So we probably could have gotten the angle correctly by recognizing our location and identifying that we just had a special angle. But were the angle not a special angle, and you will sometimes get angles that aren't special angles, you would need to recognize that the calculator would be, because of that negative side ratio, the calculator would be giving you this quadrant 4 result, and you would need to rotate that by pi radians to get your angle over into quadrant 2, which is where your point in the xy plane is actually located.